Okay, so today we're going to be talking about calculating conditional probabilities and evaluating independence using a two-way table. Okay, so in the previous lessons, conditional probabilities were used to investigate whether or not there is a connection between two events. This lesson formalizes this idea and introduces the concept of independence. Number one, several questions are posted below. Each question is about a possible connection between two events. For each question, identify the two events and indicate whether or not you think that there will be a connection. Explain your reasoning. Okay. So, A says, are high school students whose parents or guardians set a midnight curfew less likely to have a traffic violation than students whose parents or guardians have not set such a curfew? So, what are the two events? First of all, two events are curfew and traffic violations. Now, you're going to have to come up with your reasoning about the two. Are they connected? Well, you could say students that have curfews at 12 o'clock or at midnight may rush home or speed to meet the curfew. Therefore, they would get tickets, possibly. Or you could say, no, that they are less likely because they have stricter parents that are going to be watching out whether they're speeding, all that type of stuff. However you want to justify that to tell. Or you could say, yes, or no, they don't, because their students they're not going to have more traffic violations because they're not rushing home. Okay? Or yes, they have more if they don't have a curfew because they're staying out too late and they're speeding on the way to school. So there's a lot of different ways you could talk about it. Okay? B, are left-handed people more likely than right-handed people to be interested in the arts? So the events are left-handedness, and art. We're going to call it interest in arts and arts. And those are your two events. Give me your reasoning for those. Are students who regularly listen to classical music more likely to be interested in mathematics than students who do not regularly listen to classical music? So we're going to say classical music and math. Those are your two events. Okay? Whatever reasons you may have about that. All right, page 2. Are people who play video games more than 10 hours per week more likely to select football as their favorite sport than people who do not play? Okay? So 10 hours plus a week and football favorite. Okay? Now, how those two would be related, I don't know. But you could say, no, those have nothing to do with each other. Or if you can come up with some reason to say, yes, they do. That's all up to you and your justification. Okay? So this says two events are independent when knowing that one event has occurred does not change the likelihood that the second event has occurred or will occur. So this would be an independent. This question up here, just because you play 10 plus hours of sports or video games a week doesn't mean that you will choose football as your favorite. There's no way that that can have an effect on it. Okay? Now, let's look at this page. For each of the following, indicate whether the probability described is one that can be calculated using the values in table 1. And you can see those there. The probability that a randomly selected student participates in an after-schools event, after-schools athletic program. So what you're trying to do is indicate whether the probability described in 1 can be calculated using the values in table. Okay? So, can you predict or give a probability that a randomly selected student in an athletic program? Yes, you can. Because why? It's not conditional. You've not given any conditions for that. It's just any student in an after-school athletic program. Sure, we can do that. Okay? Now, the probability that a randomly selected student who is female participates in an after-school athletic program. Yes, it is conditional. What is the condition? Well, they have to be female, right? And participate in an after-school program. Okay? The probability that a randomly selected student who is male participates in an after-school, yes, it's the same thing. Yes, it is conditional. Okay? Let's go to page 4. Use table 1 to calculate the probability described in exercise 2. Well, I thought I put that on here, but maybe I did not. So, we'll just flip back and forth. It says the probability that a randomly selected student participates in an after-school athletic program. So, randomly selected student means any student. Well, how many was the total? Those were 1,000. There were 1,000 students possible, and we're looking at that participate in after schools. Okay, so we're looking at this category and the ones that participate. So that's going to be 400 out of 1,000. What is it going to be? Well, it's going to be exactly, right? We know that's going to be exactly 0.400. Okay. Now, this one says it's randomly selected student who is female participates in the activities. So, we look at the female that participates. So, that would be 232. And then how many females total? Remember, we always put the first condition that they are female. That's our total. So, that's 580. And that participated in after-school athletic programs is 232, and that is approximately 0.40. It's pretty close. Same thing. All right, so selected student is male and participates. Well, how many males were they? There were 420. And participates. So 168 out of 420. 168 out of 420. And that's going to be also about, I don't know why I want to keep putting the 0 there. 0.400. So those are all about the exact same. So you would tell whether or not, would your prediction of whether or not a student participates in an after-school athletic program changes if you knew the student's gender? Well, no, it would not change, because they have the same probability. Okay? Probability is the same. All right. Now, let's look at this. It says, to determine, or two events are independent if knowing that one event has occurred does not change the probability that the other event has occurred. For example, consider the following two events. The event that a randomly selected student is female. Okay, that's one event. The other event is the event that a randomly selected student participates in an after-school athletic program. Okay, so events F and S would be independent if the probability that a randomly selected student participates in an after-school athletic program is equal to the probability that a randomly selected student who is female participates in an after-school program. If this was the case, knowing that a randomly selected student is female does not change the probability that the selected student participates in an after-school athletic program. Then F and S would be independent. Okay, yeah, because they don't matter whether they're male or whether they're female or just in general, because the male and the females, the whole probability of that was going to be about 40% anyway. So those are independent events. It does not change the probability that the other event has occurred. Okay, so let's look at the next page. Page 5 says, based on the definition of independence, are the events randomly selected students as female and randomly selected students participate in an after-school athletic program independent? And that's just what we were saying. Yes. Yes, they are. Because the randomly selected female does not change the probability. Doesn't change the probability. Okay. Now it says a randomly selected student participates in an after-school athletic program. What is the probability that this student is female? Well, let's go back to our chart. And we have, of the students that participate, okay, the ones that participate is 400 total. And then that's female. So that's the percentage we're going to look at. So let's look at it. It'll be 232 over 400. 232 out of 400, and that is about 58. I keep wanting to call it percent, but it's really not. It's a probability. About 0.58, 58 hundredths. Okay. So using only your answer in part A, what is the probability that the student is male? Well, that's easy, because we can say 100 or 1, right, minus 0.58. And when you borrow, that becomes 42. So that means 0.42 is the male probability. That was simple enough. All right, page 7. All right. So let's consider the data below. We have asthma and non-asthmatic and household smokers and the totals. Okay. You're asked to determine if the two events, a randomly selected student has asthma and a randomly selected student has a household member who smokes, are independent. So first we're going to look, what are the probabilities that you could calculate to answer this question? Well, we're going to look at students that have asthma and the number of members that smoke. So that's going to be 182 out of 69. And then we're also going to look at the students that don't have asthma and those with non-household smokers. So we're going to look at that as 473 out of 755. So if those are about the same, then they don't have any effect, right? Those are independent. Those really don't have anything to do with it. So let's look at them. Calculate the probabilities in exercise 7. Okay. Well, let's do this as a box. 69 divided by 182. That's going to be about 0.38 chance. And we'll circle this one. And that is equal to about 0.63. Okay. Now, we can't just look at those two. We have to say, well, what about the overall? Okay. So if we come over here, we would say, if you go back up to your chart, you need to look at your 69 out of 542. And then you need to look at 113 out of your 395. Okay, so let's do that. And we would have 69 out of 542. And that is about 0.4213. And then if we did 113 out of 395, that is about 0.29. Okay. Page 8. Based on the probability you calculated in exercise 8, are these two events independent or not independent? So they would be not independent, because the conditional probabilities needed to be what? They needed to be equal for them to be independent. It wouldn't matter. They're independent of each other if those are equal. Now, they're independent because they were not equal. It can get a little confusing. If they're independent, then that would mean that they are equal. They're not independent because they were not equal. Now, is the probability that a randomly selected student who has asthma and who has a household member who smokes the same as or different from the probability that a randomly selected student who does not have asthma but does have a household member who smokes? Okay, that's a lot going on. Okay, so let's look at them again. A randomly selected student has asthma. Okay, now, who has a household member who smokes? Okay, so that's what we're looking at. Randomly selected student who has asthma. And that person has to have a member who smokes. Okay, so if we look at that, we're looking at these two. Oop. I need to not do that. Let me zoom out here. Okay. All right, let's do that now. Okay, so we're looking at these two categories here. We're going to look at the total randomly selected student and that has a asthmatic child. So that would be 113 over 182, and that's approximately 0.62. Okay, then we're going to look at the probability of a randomly selected student who does not have asthma but does have a household member who smokes. So does not have asthma. The total of that is 755. And you're also looking at the ones that have at least one. Okay? So that's going to be 282 out of 755, which is about 0.37. Let me refresh that. Okay, there we go. 37. Now, this would be different. Okay, those are different. And they would be not independent. Okay. If they were the same, then they would be independent. They need to be equal for them to be independent. Not independent means they are different. Okay. I think this is the last question. A student is selected at random. The selected student indicates that he has a household member who smokes. What is the probability that the student has asthma? Okay, so let's go back to our chart. And it said randomly selected student has at least one household member. So it's going to be out of 395. And it said, what is the probability that he has asthma? Okay. Let's make sure we did that again. Household who smokes. And what's the probability that the student has asthma? So yes, household member that smokes is 395. What would be the probability that he has asthma? That would be 113, which is about 0.29. Okay, so if you're in this statistics, in this study, it said if you are selected and you have a household member who smokes, then the probability of you having asthma would be 0.29, which is greater than 1/4, a quarter of this chance, the possibility. All right, let's look at this lesson summary. Data organized in a two-way frequency table can be used to calculate conditional probabilities. Two events are independent if knowing that one event has occurred does not change the probability that the second event has occurred. So, probabilities calculated from two-way frequency tables can be used to determine if two events are independent or not independent. All right.